Good morning, everybody. Welcome to Prague. I have a small confession to make. I'm very bad at waking up early. So when they put me here in the spot on, well, morning, I cringed a little bit, but I managed. I'm here now, and I'm going to tell you about a little other confession that I have as well. That is, I said in that title, writing more robust XSLT style sheets by, understanding and leveraging the XDM data model. After I sent that in, I was thinking like, yeah, well, that's a whole mouthful, but maybe we can just simplify that a little bit and just call it type systems. So I'm going to talk a little bit about how you can, I think I'm a little bit too loud, no? No, it's okay? All right. So we're going to talk a little bit about type systems in XPath, XQuery, and XSLT. Better? Oh, yeah. Let's start with a little query. Query not in the sense of XQuery, but as a question. What could go wrong here? Sorry, you were saying? The microphone can go wrong, yes. Well, this code will never fail with an error, but things that can go wrong here is that, well, there's no person in the items that you're matching against, or that it's not at name, but maybe it's at naam in Dutch or something, like you have a typo. But you will never see that when you're running your style. So you just get output with missing data, and you have no idea where it comes from. Types can help you with that. That's what we're going to talk about. Here's another example. Another question. What could go wrong here? Looks pretty cool, right? I mean, we have a param named items. We match against some root. Then we apply the templates against the item of the param $items. And as it is written here, it would be fine, but it's a param. And a param can be set outside of your style sheet by the processor. And if it doesn't have the right type, I mean, if it doesn't have items or if it just has element item, then again, we run into the situation that we don't have any output. So again, types to the rescue. Yeah, we're going to talk a little bit about history of types. It's a curiosity of myself. I didn't really know where the type system, the XDM, the data model in XPath comes from. Then we will go over a basic overview of the types that we have. We look at some special types and how to use them, or more specifically, how to not use them, and some peculiarities and some pitfalls. It may be a little bit surprising, but long before the first computer came around, even mathematicians were struggling with set theory. In Cantor's set theory, there was like a new mathematical concept, and they needed a language to describe this set theory. Frege started that somewhere around 1879, didn't really get it done, and then Russell put a lot of work to it, and he came up with a language and a kind of formulation and types, and he wanted to publish that in his Principia Mathematica. But just before he published it, he found out that it didn't quite work. And his problem comes from what they now call the Russell's paradox, that that a type cannot contain itself. So when you end up, from the look of set theory, you can see it as take the set of all sets, for instance, that don't include themselves. So the set of all sets that don't include itself, should that then include that set? But if it does include that set itself, then it's both self-referential and it includes itself. But if it doesn't include itself, then it misses the set. This kind of gave a lot of problems for many years, for many decades. And even 10 years later, the same Russell wrote in his Introduction to Mathematical Philosophy that now the theory of types emphatically does not belong to the finished and certain part of our subject. Much of this theory is still inchoate, I don't know what that means, confused and obscure. He was saying, I give up, I don't know how to continue. There are paradoxes, I cannot resolve them. Alonso Church came to the rescue by proposing a simplification, but others were not really happy with the simplification and continued working on it. Gödel continued working on the theory of simple types. Then Curry, who people may know from the language Haskell or from a lot of foundational groundwork in functional languages in general, and therefore, in the end, also XPath, he said, I do not run away from paradoxes. It was in reply to the Church and Klein and all the others and Russell saying, well, we have a paradox, just live with it. He says, I don't want to live with it. Unfortunately, he came with his own paradox as a result of that. His problem was he wanted to describe functions for everything. Everything is a function, the lambda calculus. And he found out that he could not reference itself. So a function cannot contain itself. And that by itself is Curry's paradox. One other way of looking at these paradoxes, like in normal language, is the so-called Barber paradox. That's the one that I usually kind of understand within a few minutes. If you have a barber who shaves all men that do not shave themselves, and only men who do not shave themselves, should this barber then shave himself? That's a problem, right? I mean, if he shaves himself, then he doesn't belong to the men who shave themselves, or who don't shave themselves. But if he doesn't shave himself, then he is all shaven, and so he needs to shave himself. So it doesn't work. That will help. So how did this come down to XPath? Well, XPath, XSLT, and XQuery, they are all functional languages, and they have their foundations in functional languages. As for that, they basically also have their foundation in lambda calculus from Curry. The relation that we'll talk about is about a type system which comes from XML schema, is described in the XML data model, short for XDM. It's used in XPath, and XPath is then the basics for function and operators, which is then the query language used in XSLT and XQuery. So what did they take away from all the rules that Curry and others put down? Types, as we have them in XPath, they cannot be self-referential. Now, you may shout out and say, like, wait, is that true? Because you can have a schema, and you can define an element in a schema that references another element. So you have like a para that can contain a para, that contain a para, that can contain a para. But that is the description of the type. But you cannot create a type and say, like, this type is itself. Because all these nested paras, even though they look the same, it's a description of these paras, they don't point back to themselves, because then this para chain would be infinite. This is not permitted and not possible. As a result, types are deterministic and types are essentially finite. That doesn't mean that you cannot have like an infinite structure, but any instance of a type will always be finite. An important concept for people that come from the OO world, object-oriented programming. In object-oriented programming, it's very normal to have a type and that contains data, and it also contains the operations that you do on the data. Not so in XPath, or basically in any functional language. Types are data. Data does not have functionality. Functionality is the description that you, the things that you do with data, and you describe that in functions. The immutability concept results to that any instance of type always belongs to one and only one type. This is also true for unions. A union is a type that actually consists, it's like saying this can be an integer, it can be a string, or it can be a decimal, or something else. And that is like the union. But at the moment that you have an instance of a string, and you say this is this union, then that instance itself is actually a string. It's not a union. You cannot say this instance is maybe an int, maybe a string. You can code about it, but the actual instance will be, in that case, a string. Sequences are countably infinite. With that, I'm not even sure if that's the right term, but it means that we describe them as infinite, but the whole sequence, at least theoretically, will be presented in memory. So it's always a finite sequence, even though we describe them as if they're infinite. Maps and arrays share a common type. I don't mean that maps and arrays are like the same. I mean that the key of a map, like when you have different different keys, let's say the key is a string and another key is an integer, then the processor or the type system demands that is described as a key of any atomic type. To see that in practice for a moment is to get an idea. Let's see. This is readable, right? Good. So this is basically a REPL environment for XPath. And if I have... so this extension function I just wrote to make it easier to demo these things. It's the type info string shows what type it is as a string. And what I have there is a map. The key here is a string, and the values are integers, and that's exactly what it shows. Now, if I change that, where is it? Oh, I have it somewhere. So if I change that to, say, one integer and the other one being a sequence of integers, then the type of the map will also change. And if I change the second key to be something else, then you'll see that the key automatically changes. I call that kind of like the maps are morphological. They change while you're using them. By the way, I say they change, but every map is its own instance. You cannot change the data. You return a new instance of the data. Okay, some type basics. Often when I talk about types, I confuse myself the concept of an instance of a type and the concept of a type, which is the description of the type. So if I say to my variable that it should expect an integer or a string, then that is the description. At the moment that I set this variable to a certain value, then that value is an instance. This concept is important because let's say you have an XS integer question mark, so it can be either an integer or an empty sequence. Then the type is basically type XS integer, but at the moment that you're running it, it could just as well become an empty sequence. Likewise, you could have a byte which you store in a type that expects an integer. Is that me? Oh, wait. So everything is an item. Item is on the top of the hierarchy of types. Everything is a sequence. I'm sure some people have seen the little star that you sometimes put behind your type saying, I expect 0 or a lot. This star was once invented also in type theory and set theory by Kleene. And there's a special case, empty sequence. This is actually accepted as a sequence type. So you could say about a function that it returns an empty sequence, but it wouldn't make much sense because since things are immutable, it will always return an empty sequence, so it doesn't ever have to evaluate that function because, well, it will be empty anyway. But sometimes it can be handy in cases where you want to inspect if a type is actually an empty sequence. Here's a quick overview of the type hierarchy as published in the XPath specification. It's actually in the FNO specification, but anyway. Item on the top, from there comes the nodes, functions, and all the atomic types. So these atomic types, is it because I'm standing there? I can go here. I don't like standing behind the desk. You want me behind the desk? Oh. Such a pity. Okay, well, then I'll stand here. Can't read it then. The set of primitive types, integers, strings, all the primitive types are also atomic types. They are not nodes. Also dates and times and base 64 binary, which is essentially a byte array. Node types, I use here simple node types because there's no such concept as simple node types and complex node types, but when I say simple node types, I mean like a simple description of a node type. This description you can use in a basic processor. You don't have to have a schema-aware processor to say, I expect an element of type celery. What you're saying is not that it belongs to a schema type, but what you're saying is, I expect this element to have name of celery. That is actually a very handy concept, and whenever I review code from others, I see it's very rarely used. But if you declare your variable to, and your other items, functions, and so on, to what it expects, then when you run your style sheet or your XPath query or your X query, and you get early type errors instead of, like from the very early slides in the beginning, totally empty results, which is not very nice. Complex types are types defined in a schema. They have no constructor. Nodes, also complex types, they don't have a constructor, but the primitive types and the simple types, they all have a constructor with the same name. So the simple thing to create a byte is to write XS byte, and between quotes, you say, between parents, you give the value. I find it a little bit unfortunate that we don't have constructors for elements.
elements and such. In X squared, that's not really a problem because you can write them directly. But anyway, in XPath itself, it's kind of impossible. So this is, again, from the XPath specification, the full hierarchy of all the basic types that are supported by any... Really? Come on! Maybe more in the middle, as it's... we'll see. What? No, that's another kind of sound. This is my shirt. When the specification or any description you see about types talks about primitive types, they mean actually the top hierarchy here. So a primitive type, I think there were 19. It's like XS duration, XS time, XS decimal, but it's not the derivations of them, even though all these derivations, like integer and long, they also belong to the set that are supported. But if any, what, already 5 minutes, really? That's because them. So, well, good. Then we're gonna rush through the next 2 on the slides. Type coercion. When you declare your Excel variable and you say s equals something, or when you have a function that expects a certain type, type coercion makes sure that the right type goes in, but it's not exactly the same as an instance of that type, because in some cases, like when you use an attribute of your tree, it actually has an untyped atomic type, and type coercion makes sure that it will try to convert that into the right target type. And, well, there's no time for the demo on how these things actually relate. I wanted to show that. Instance of, there's implicit type conversion, atomization. You can use functions that expect an int, but then when you call them with data from your tree, then again, this is called untyped data, and the processor will convert that for you. At least it will try, or it will throw you an error. That can be a blessing and a curse, actually. And I find it much easier myself if you explicitly say, let's cast this thing to an integer because I want an integer. Let's cast this thing to a string. Well, a string always works, but let's say a datetime, because then you get an error on that cast and not much further down the line. Functions, we're going to skip functions then for today, maybe next year. And there are some things to say about special types. Namespace types, they kind of keep their namespace around, which, it can be context dependent on where you're using them and so on, or when you're declaring them. Abstract types, no time, error types. Yeah, there is in, I think it was in XPath 3.1, they introduced XS error. It's a very peculiar type because it doesn't really do anything. It's an empty type, it's an empty union. So there's no possible way to create an XS error. And you might think, like, in what world would that be useful? I haven't found many use cases, but suppose you have a function that writes like a trace or something and then throws the error that it just caught, because, you know, in XSLT3 you can have a try-catch. Then you could throw that error again and you can describe that function as returning XS error to say what it's doing. Yeah, and if an error, it does not return XS error. I think that's actually an error itself in the specification, but that's, we'll get to that later. Union types. A quick note on untyped atomic and XS untyped. There's a lot of talk in the specifications about what is going to happen when you're accessing data in a tree. And it explains that any attribute has a typed value of X is untyped atomic unless it's validated, in which case it can actually get another type. That's for a schema-aware processor. This leads to a problem, because when you write code that expects untyped atomic, and then you think, oh, I just bought this very nice schema-aware processor. Let's run this same code with a schema-aware processor. And all of a sudden, the schema-aware processor, because you wrote this nice schema saying that it's not untyped atomic, but it's actually a datetime, it doesn't accept your data anymore because it's not an untyped atomic. So when you use functions that can accept an X as untyped atomic, just use them, no problem. But don't describe your own data as X as untyped atomic, because the minute you will actually want to be more specific, it will blow up. X as untyped, something you cannot use. It's kind of you cannot use it directly. It kind of means that an element has not been validated yet. Yeah, 1 minute, almost. Yeah, you get 3 seconds to look at this. We're gonna skip. Atomization is I could actually spend an hour on talking just about atomization. So 1 minute is not enough for that. Let's have a quick look at the pitfalls. Maybe we still can do that. So I have a variable items. We kind of saw that in the beginning as well, right? And I'm going to match over that variable $item/item. This all just works. No problems here. Now, I think I learned something about types. Let's use these types. What's happening here? Anybody? No? No. No, I have the same problem. I mean, it's still the same, right? It's the same code. But the thing is, in all our wisdom in writing the things about XSLT2 and everything, we decided that when you add the S clause in an XSL variable, then the implicit document node that the variable contains is not there anymore. So what you're having here is not a tree rooted at the document node, but you have a bunch of elements. So $item/item doesn't exist. It's just $items. Sorry, what? Oh yeah, thank you for that. I've copied that code a few times, never saw that it was wrong. But that was not actually the point I was trying to make. It's that one that /item doesn't work. But thanks for pointing that out. So earlier I mentioned about not using X as untyped atomic and X as untyped. Just don't use it. You make your code less portable to a schema-aware situation. This slide, do we download slides later? I can ask you to look at this later and dream on it a little bit. Sorry? What, I still have 1 minute? 0 minutes, right? -1. Yes. So, to sum up, use types to describe your code. It will make it clearer. You get earlier errors which actually help writing better style sheets or XQuery. Keep it simple. Yes, and thank you. Did I really talk half an hour?
Thank you very much. We have a few minutes for a question. Very interesting presentation for something terribly complicated. Like types, as you said, you may need maybe 1 hour to talk about atomization only. So any question? Anyone awake? Oh, Michael. Yeah,
Liam.
first.
And
Liam first, okay.
Oh, okay. Liam Quinn, Delightful Computing. Thank you for that talk. Of course, early on in XQuery, there was so-called pessimistic static typing. And This was absolutely
Pessimistic
fabulous.
static typing, you said?
Pessimistic static typing.
Static, not static. Okay.
It was done at compile time, and it found all sorts of things where your program might possibly go wrong. And it was almost impossible to write anything, but if you did manage to write anything, it usually worked, right? And the great thing about what we've ended up with in XSLT is that you have opt-in pessimistic typing. So really, really want to second your talk. Thank you.
Was it a question? No, okay.
Yeah, I wanted to put static typing in the talk, but I think that would end up minus 10 minutes extra.
Abel, there's one statement you made.
Yes.
With feedback map, they don't have a type label. A map belongs equally to a map from strings to elements, and from a map from any atomic to processing instructions or something. There's no single type label attached to a map. It's simply a type is just a predicate. You can ask whether something is an instance of a type, but you can't say what type are you. There's no one distinct, unique answer to that.
But you can ask whether an item is an instance of a certain type of map.
You can, yes, but it could be an instance of many different possible types of maps.
It's a vertex.
Yes,
It's a
that's
vertex
correct.
of map.
One thing that is labeled with that says this is my type.
So there's actually the part about the morphological map, what you're explaining. I mean, because it basically contains any kind of item. Yeah. But at any given moment, the map, because it's immutable, can only belong to essentially one type of description.
It's an instance of many, many different map types.
Okay.
Vertices.
I have to chew on that a little bit.
Any other question? Thank you very much. Thank you, Adam, again. You need another slot for the rest of this presentation, I think.
Another what?
Another slot. Another